once again. All right, class, so yesterday you should have finished up on graphing families of functions, so we can check that off for the booklet. You should have done the practice. So today we're going to talk about transforming those families of functions. Now, there are many ways that you can transform your parent functions that you already have to create the other functions in the family. But the one that we're going to talk about first is called a vertical transformation. So we can transform functions vertically by using addition or subtraction. So I'm going to explain what I mean by that in a second. So for example, if we look at our parent function f of x equals x squared, then, so if we make that g of x, then we're going to look at, or if we make x squared f of x, sorry, as you can see right there, g of x is going to be x squared plus 3. So by adding 3 to our parent function, we're going to transform that function by moving it up by 3. So we're going to start by graphing our parent function because we already know what it looks like. F of x squared is a parabola starting from the center going out. Then we're going to use our table to help us graph g of x. So we already know for f of x how to find that. So we're going to start by filling out this column. So negative 2 squared equals 4. Negative 1 squared equals 1. 0 squared equals 0. 1 squared equals 1. And 2 squared equals 4. So that's easy enough. So now if we want to find g of x, well, we know that g of x is just f of x plus 3. So we can take our f of x column and add 3 to get g of x. So if we have an input of negative 2, we're going to have an output of 7. For negative 1 plus 3 is 4. 0 plus 3 is 3. 1 plus 3 again is 4. And 4 plus 3 is 7. So now we can start graphing our points to start to see what this is going to look like. So we have negative 2, 7, which we can graph up here. We have negative 1 and 4. We have 0 and 3, which is going to be right there. We have 1 and 4. And we have 4, 2 and 7. Now, what does this look like? Well, if we fill in the dots, it starts to be a little bit more clear. So we start out there, we come in. So it looks like to me like we have another parabola, but it's shifted up by 3 units. So if you thought that as well, you were correct. So adding 3 to x squared is just going to shift our graph up by 3 units. So we had our original graph and it went up by 3. So everything got pushed up by 3. So using our original parent function, which we know what it is, we can shift it up or down to find any other x squared plus or minus for any number. So just to continue that a little bit, we're going to look at what happens if we subtract 4. So we're going to look at, this time, our parent function f of x equals x. Now we know what this looks like. It looks like a straight line. So f of x equals x. So what's going to happen when we subtract 4? Well, we know that it's going to shift down by 4. So we're going to start here, and now we're going to have another line. So f of x is up here, our original function. G of x is just the same function shifted down. So it shifts our function down by 4 units. So adding is going to shift our function up. Subtracting is going to shift our function down. So the last thing that we're going to look at is the square root function. Now, this is going to work the same way the other ones worked. So first, we're going to start by graphing our parent function, f of x equals x squared, which is going to look something like that. Now, if we want to graph square root of x plus 3, we are going to take our original function, we're going to count up by 3, and then we're just going to do the same thing. So we're going to go out and go like this. It still doesn't take anything in the negatives. We're going to be going to the right still, going up the same amount. We're just starting up by 3. So adding, this should be 3. Adding 3 shifts our function up by 3 units. So hope this is starting to make sense for you. If it's not, ask us for assistance and work it out through the practice. Good luck and have a good day.